Okay, we are being recorded. Okay, Marin, can I do something like number 1 on the quiz, please?
Sure.
Marin, would you like me to do the actual number 1 or pick a problem, a different function, and do the same thing that was on the quiz? I don't care either way. I'm going to turn on my fan while you answer that. Okay. All right, different function, please. All right, let me look one up. Chapter 5. Okay. I'm just looking for some appropriate equations that I can use. Okay, let's use this. So I am choosing an equation from page 187. And I'm going to go number 42. That's actually similar to what yours was, in that it opens down. All right, so here's the equation. Y equals negative 2x squared plus 4x minus 3. Okay, 3 messy minus 3. Minus 3. Okay, so let's assume that the exact same directions are given. So they say use this function. They put f of x instead of y, but you know that means the same thing, right? And the first set of directions say transform the equation into vertex form. So there is a manner that you can take this equation from standard form and use completing the square to change it to vertex form. And by far, the easier method is to make sure you have memorized the opposite of b over 2a, and then I'm just going to put comma question mark. You take that value, the opposite of b over 2a, that's going to be your x coordinate of your vertex. Let me squeeze in a capital V right here. This is going to be your vertex, and then when you get your x, you go back and plug it into your function and figure out what your y is. All right, so in this case, I'm going to go negative 4, that's the opposite of b, and then 2 times a is also negative 4, and so I get 1. That's my x coordinate of my vertex. And if I go back and plug that in, first I square it. So I get 1 times negative 2. I'm just going to put my work right under here, negative 2. When I plug in 1 for x, I get plus 4 for my second term, and then minus 3. So that is negative 5 plus 4 is negative 1. And so that is my vertex. All right. Eventually, they're going to ask us to graph this. So I'm going to go ahead and start my graph right now. And this is going to open down. So I'm going to go like this. All right, so 1, negative 1. There's my vertex. And as soon as I plot my vertex, I suggest you draw, well, if you're in my class, you need to draw your axis of symmetry. Okay, and so eventually here they asked you to write the equation of the axis of symmetry. So in this case, use a different color. That would be x equals 1. It's a vertical line. You have to put the letter x. If you just put 1, it's not really any big secret. We know you don't know which variable to write. So x equals 1 is the equation of that vertical line that's called the axis of symmetry. All right, next they asked for, well, they asked for the coordinates of the vertex, so I'm going to box that. It's 1, negative 1. Okay, then they say find the y-intercept. Well, if you look at this equation in standard form that they had originally given you, box that, that's what was given. If you just look at the c value, negative 3, that is your y-intercept. Because if you plugged in zeros for x, your first two terms would become 0. And so you would get y equals -3. Now that point that I'm plotting right now on the y-axis, do you agree that is 1 unit to the left of my axis of symmetry? So I'm going to go 1 unit to the right and put the same y value. So that's like a 2-for-1 special. You figured out your y-intercept and you found your point of symmetry. By the way, they asked you that on the test or on the quiz, find the symmetric point. Okay, so this would be considered the point that is symmetric to the y-intercept. Okay, so the y-intercept, I know Mrs. Bright wants you to say that the y-intercept is 0, -3. Okay, and depending on your teacher, they may accept just -3. And then this point of symmetry is 2, -3. Okay, so that's another answer they asked for. And then I've already written the equation of the axis of symmetry. Okay, then E was sketch the graph showing the vertex, the y-intercept, and the symmetric point. And so they really only specified those 3 points that I have right there. But if you're in my class, I want a minimum of 5 points because these 3 points really are not enough to be able to draw an accurate graph. So since these 3 points are pretty close together, I'm going to go out from there, and I'm showing you with my hands that I'm going to go out in the x direction, because if you're going to go plug something into your equation, aren't you going to plug in for x? Okay, so you can either go to the left of that y-intercept and plug in -1 for x, or you can go to the right of that point of symmetry and plug in 3 for x. A smaller number is a little bit easier to deal with. However, it is negative, and that makes me nervous for you guys. All right, so let's plug in 3 just for the fun of it. All right, so I'm going to just start to show that my point is 3 comma something, and let's go figure out what that is. All right, so 3 squared is 9 times -2 is -18, and then 3 plugged in for my second term becomes +12, and then I have -3. All right, so -6 minus 3 is -9, and so let me extend my graph here. So I have -3, 4, 5, 6, 7, 8, 9. So if this is -9, then I got 3 -9, this point right here that I'm plotting. And isn't that point 2 units to the right of my axis of symmetry? So I'm going to go 2 units to the left. And my 9 is kind of a little in the way. And now I'm going to try to draw. This is not easy to draw on, so you can do a better job with your picture. But there's my first half, left half, and then this is supposed to be a smooth curve. It's very hard to draw on this thing. Anyway, you should have a nice looking smooth curve parabola. Okay, they are not rays, they are curves. Okay, all right, so there's your parabola, and let's see, that's all they asked on the quiz for number 1. So I'll just stop there. Okay, there you go. Okay, Savannah, can we do something like number 3 from the quiz? All right. Let's see. All right, they gave us an equation, quadratic equation, and asked us to complete the square. So I'm going to pick a different function than the quiz, just to give you more practice. I'm looking for where they taught us to complete the square. Well, that's all right. I'm just going to pick one. All right. I'm taking this equation from page 180, but that doesn't really matter. So I'm just going to title this Completing the Square. Okay, so if they give you x squared minus 8x plus 21 equals 0. All right, so first step is to leave your first and second term alone and bring the constant term to the other side of the equal sign. So I get -21, and then I'm going to write plus blank and plus blank. All right, so because my leading coefficient is a 1, I go to my middle coefficient, this -8, and you take half of that, that's -4, and then you square it. And so I get plus 16. Well, I have to add the same thing to the other side. to balance it out. Okay, this left side is called a perfect square trinomial. You don't really have to know that yet, but when we get to factoring, you will definitely learn that terminology. So that's called a perfect square trinomial, and it's factors into the square of a binomial. So that's what I've written underneath it here. I just put parentheses for my binomial, and then I put the square right there. So here's how you get it, and this you pretty much should know from your Algebra 1 days. So I'm going to take the square root of that x squared, and I get x. And I'm going to take the square root of that 16, and I get 4. And then I look at my middle term. The sign of the middle term was negative, and so I get a negative here too. So if you square the quantity x minus 4, you will get x squared minus 8x plus 16. Okay, so we're factoring it into this. Then I combine my negative 21 and my 16, and I get negative 5. Okay, next I'm going to take the square root of both sides, but as soon as you say I'm taking the square root of both sides, I want you to say, but don't forget plus or minus. So I'm putting my plus or minus sign big and in red next to the number side, the square root right there. Okay, so I'm going to get x minus 4 on this left side when I take the square root of that quantity squared. The square and the square root cancel, so I get x minus 4. And then here I have plus or minus my rad 5. I'm just going to write like that. But then the square root of negative 1 is I. Okay, and depending on your teacher, I'm not sure if they put the I in front of the radical. My students, you know, I don't want the I in front of the radical. So you just need to ask your teacher what they want you to do. All right, but I'm not quite done yet. I want x all alone. So, of course, I need to add 4 to both sides. And then plus or minus the square root of 5 times I. And I'm purposely putting my I so that there's no question in anybody's mind whether it's inside or outside the radical. Some of you need to work on that. So I'm emphasizing by writing my answers like this, that I'm writing my complex conjugates. I'm going to write the plus or minus in A plus or minus BI form, where they're two separate terms, and the B is in front of the I, even though it's a radical. Okay, so those are your two answers, and I solved that by completing the square. Okay, let's see. All right, that was for Savannah. All right, Dylan, word problem from the quiz. All right, so this is my sample word problem. That means I'm not doing any more word problems from the book, okay? All right, just because they're so time consuming and I don't want to spend our whole time working on word problems. Okay, so this says when a football is thrown, it reaches a maximum height and then it comes back down. Assume, therefore, that a quadratic function is a reasonable mathematical model for this situation. Okay, so at least on your group quizzes, I've only graded first period, but first period you guys did great getting your equation. Okay, but again, we need to be realistic. Just because your group got the answer to the equation correct doesn't mean each individual can, so make sure that you can personally get this correct. Okay, so I need to have 3 points to be able to find this equation that I'm going to start off writing. Y equals ax squared plus bx plus c. The 3 things that I'm looking for are the coefficients, the a, the b, and the c. And since there are 3 of them, that means I have to have 3 equations because I have 3 variables to solve for. Okay, I actually thought some students would come up during the quiz and say, why are there only 2 points? Because let me just read this whole thing. It says the quarterback from LAHS throws the football to his wide receiver from a height of 2 meters above the ground. At times of t equals 1 and t equals 2 seconds after the ball is thrown, the ball is 12 and 10 meters above the ground respectively. So I was expecting students to say, okay, if I have, 1 second and 2 seconds after the ball is thrown, then the height is 12 and 10 meters above the ground. By the way, they told you let t equal the number of seconds that have elapsed since the ball was thrown, and let y equal the number of meters the ball is above the ground. So they straight out told you your y is the distance above the ground. So that's how I know to write those points that way. All right, so there's one little piece of information that I haven't used yet. It said the quarterback throws the football to the wide receiver from a height of 2 meters above the ground. That is giving you your 0, 2. So you had to realize that, you know, at the time that he throws the football, that's time equals 0, and it's 2 meters above the ground. So doesn't that give you your c, because if you plug in 0 for x, your first two terms will cancel out, and you get c equals 2. Okay, so just from that first point, I already know, I'm going to put this in red, my c equals 2. All right, so that made this problem a lot easier because now I just have these two equations to write from these 2 points, and I only have a and b to solve for. So I'm going to write the 12 instead of y, and now I'm plugging in 1 instead of the x. So I square my 1, I still get 1, and 1 times a is just a. Then I plug in 1 for my second term for x, and I get b times 1, and so that's just b. And now you don't just ignore the c. We know that it's 2, but you have to write plus 2 because that is your c. Okay, there's my first equation. Second equation, I plug in 10 for my y. When I plug in 2 for x, square it, you get 4 times a, so 4a, and then plus 2b, and again, you write plus 2 because your c equals 2. All right, let me show this in red. I'm going to subtract 2 from both sides. So on this first equation, the 2 will be gone there, and this 12 will become 10. And then here, second equation, I'm going to subtract 2 from both sides again. And so I get 8 on the left side, and the 2 is gone on the right side. Okay, I notice in this second equation that I could divide both sides by 2. There's a 2 in common with each of these. And then when I look right above that equation and I notice a plus b up there, I think to myself, let's divide by a -2, and that will allow me to cancel my b's once I do this. All right, so from this second equation, I get -4 equals -2a minus b. And so this first equation is awfully far, so I think I'm going to rewrite it. I have 10 equals a plus b. And so you can see that when I add these two equations, my b's will cancel. So I get c equals -a. If I multiply both sides by a negative, I get a equals -6. Okay, so now I'm going to go back and plug that in. I think I'll use that first equation that says 10 equals, instead of a, I'm going to put -6 plus b. So then to get b all alone, I need to add 6, and so I get b equals 16. All right, I'm going to write my answer in green. I think my answer is y equals, a is -6x squared, b is 16, so plus 16x, and then my c is 2. Okay, now I'm not just going to hope that that is correct. I'm going to go back and take my 3 points, plug them in, and make sure that they work. And I don't mind if you use your calculator. I'm going to right now to save a little time. All right, so my 0, 2 is pretty quick to see that that's correct. Okay, if I plug in 1, I'll have -6 plus 16 plus 2, and look at that, it equals 12, exactly what I wanted. And now when I plug in 2, that's going to be -6 times 4 plus 16 times 2 plus 2 equals, and I get 10. Okay, so I plugged in my 3 points, and I know that this equation is correct. Okay, so next, that was part A. Next it says, what is the maximum height that the football reaches above the ground? And they tell us to round to the nearest tenth. Okay, so just from that direction, I know I'm not going to end up getting an integer, okay? All right, so I'm going to go to the next page, and let me write my equation here up at the top. We got y equals -6x squared plus 16x plus 2. Okay, so there's our equation. And since they're asking for the highest point, it says, what is the maximum height that the football reaches above the ground? Aren't we looking for our vertex? Because this is a parabola that opens down. I know that because of my -a, that -6. And so the highest point will be the vertex. So I'm going to do what I just did a few minutes ago and use -b over 2a. The opposite of b is -16. 2 times a is -12. And so I get, if I simplify by 4 and cancel my negatives, I get 4/3 for my x, and then I'm going to go and figure out my y. Okay, so I'm actually going to write my point a little bit bigger here. So 4/3 is exactly my x, and to figure out my y, you can just plug that in if you want. And remember, they told us to round to the nearest tenth. By the way, this y that I'm going to get is the maximum height that I'm looking for, because remember, our points were X is time, so this 4/3 means 1 1/3 seconds after the quarterback threw the ball will be at the highest point above the ground, and they told us to round that to the nearest tenth. And so I get 12.7. I believe it's 12.66666, but they asked us to round to the nearest tenth, so 12.7. Okay, so that answer, this is part B, would be approximately, I'm going to put my squiggly equal sign, 12.7 meters. It is a word problem. You need to put your units. Okay. All right. Next it says the wide receiver misses the pass and the ball lands on the ground to the nearest tenth of a second. Again, they're telling you you're not going to get a nice neat integer. To the nearest tenth of a second, determine how many seconds the football is in the air. Well, the quarterback threw the ball at time equals 0. And so if you can picture the ball starting at 2 meters, and then it's going to go up, 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 highest point, and then come back down. And if nobody catches it, it's going to hit the ground. Well, isn't that the x-axis? So they are basically asking you for the x-intercepts. So for C, I'm going to take my equation, plug in 0 for my y, write the rest of the equation here. Negative 6x squared plus 16x plus 2. Okay, I plugged in 0 for my y because I'm looking for my x-intercepts. All right, so x equals the opposite of b, plus or minus. B squared is 256. I suggest you write minus 4, write out your a, write out your c, and we'll go back and simplify that in a moment. And then all over 2a is negative 12. Okay, when you simplify what's inside the square root, you just need to be careful. You end up getting the square root of 304 all over negative 12. Now, remember, they told us to round to the nearest tenth. For that reason, I'm not going to try to simplify my radical. That is a radical that can be simplified because I can see the perfect square 4 is a factor of 304. But I'm not even going to try to simplify that. I'm just going to plug it into my calculator, and you better make sure you know how to, and find my two values. So when I try my first value, when I do the negative 16, I believe it's plus the square root of 304, and then divide that by negative 12, I get negative 0.1. Well, that's going to end up getting rejected because I'm stopping to think, my time cannot be negative, right? And the graph, when we do graph this, will make this answer actually make sense, okay? But it needs to get rejected. It's not part of the domain. And then when I plug in my other one, negative 16 minus 304, square root of 304, and then divided by negative 12, for that one, I get approximately 2.8. And so that is going to be my answer to part C. Okay, the ball was in the air approximately 2.8 seconds. Okay. All right. Next, they ask us to sketch this, and it says in the appropriate domain and range. Okay, so when you guys go to do a sketch, you need to think about what is appropriate for your scale. Okay, so we know time is our x-axis, and distance above the ground is our y-axis. And I'm just going to go back and look at my points that I have. Well, they gave us 3 points, okay, 0, 2. They gave us 1, 12, and they gave us 2, 10. Well, of course, those should be in your graph, okay? And many of you did not do that. Then I found the vertex to be, I'm going to write 1 1/3. Remember, that was our 4/3. And then we said that was approximately 2.7. Is that true? No, it was, I'm sorry, 12.7. There we go. 12.7. Okay, so that's our vertex. And of course I should have that. Okay, so as I look at my x's, it goes from 0 to 1 to 2. I've got that 1 1/3, so that's between my 1 and my 2. And then, remember part C, let me go back a page. My part C was to figure out how long the ball has been in the air. It's been in the air for 2.8 seconds. So that is less than 3. So look at what I'm going to do with my x-axis. I'm going to go, here's 1, here's 2, and here's 3. Your x-axis scale should be nice and big so that we can really see what's going on here. Okay, now my y's, on the other hand, go up to 12.7. That is the highest. So I'm going to go by ones. Let me label that 1, 2, 3, 4, 5, 6, 7, 8, 9. I know I have a point to plot at 10, so I'm going to label that. 11, 12. I know I have one at 12 also. And then 12.8 is, or 12.7 rather, is close to 13. So I'm going to label those points, okay? All right, remember they said when he threw the football, it started at 2 meters. Let me do this in red so it shows up a little bit better. So there's my y-intercept, okay? Then I have the point 1, 12. So I plot that. Okay, 1, 12. Okay, let's go ahead and plot 2, 10. And then don't forget that we know that our ball was in the air for 2.8 seconds approximately. So here I'm going to put my 2.8 on the x-axis. That's when the ball finally touches the ground. Okay, here's the part that some of you did not do. Your vertex, you figured it out. They asked you to, and it's at 1 1/3. Sorry, this isn't straight. Okay, and then my y is approximately 12.7. So up here. Okay, and now what you should be doing, now that I have my vertex plotted and my axis of symmetry kind of dashed right there, is put a bunch of points of symmetry. Okay, so isn't that 1/12, 1/3 of a unit to the left of my axis? So watch what I'm going to do. I'm going to put 1/3 of a unit to the right of that axis. Okay, then look at my 2, 10. Isn't that 2/3 to the right of the axis of symmetry? So I'm going to go 2/3 to the left and kind of eyeball where that might be, about right there. Okay, so now watch what I'm going to do to the left. I'm going to try to do a smooth curve. That goes from there. That's supposed to be going right to that y-intercept. Okay, and by the way, I can also do a point symmetric with the y-intercept. That's 1 1/3. So 1 1/3 will be about right there. I am kind of eyeballing this. Okay, but now I've got another point that I can use to do a nice, nice accurate graph. Remember, it's a smooth curve. Oops. You just need to be understanding and know that this is difficult to draw. Okay, but you guys should be able to draw a pretty accurate graph. All right, but do you see the symmetry with my graphs? Some of your graphs on your quizzes are not symmetrical at all, and that's not what a parabola does. Okay, so the more points you have, the more accurate you can be. Let's see how many points I just plotted. 1, 2, 3, 4, 5, 6, 7, 8 points I have for this very accurate, albeit a little bit wobbly, parabola. And I didn't plug anything in to get those. I already had them from what they gave me and from what I answered, and then I just did points of symmetry. Okay, all right, I hope that was helpful. All right, okay, let's see, that was for Dylan, and I'm sure a lot of other people. Okay, Phoebe, can you just do a graph from the word problem? If you mean the one I just did, yes, I just did that. But Phoebe, if you mean a different word problem, you know what? You can't just do a graph from just the word problem because you have to go and answer their questions. Then that gives you other points. You know, when you think about this one, I just did the whole word problem, and that's why I was able to get so many points for my graph. Okay, Kenji, can we do something like number 6 from the quiz, please? All right, and number 6. Okay, quiz number 6. All right, so it says, suppose f of x, another name for f of x is y, if f of x equals x squared minus 2x plus 10, and it says find x if f of x is 4. Okay, so another name for f of x is y. They are giving you your y, and so it makes complete perfect sense that they're saying solve for x. So instead of this f of x, I plug in 4, and then I have the rest of my equation, and I just need to solve for x. Well, anytime you have a quadratic function and you're trying to solve for the variable, you want your other side to equal 0. So I have to subtract 4 before I can start using any technique, whether I'm going to complete the square or do the quadratic formula. I need to subtract the 4. Okay, so I noticed that my first leading coefficient is a 1 and that my middle coefficient is even. So this is such a perfect candidate for completing the square. So as you know, you subtract the 6 to the other side. Notice I left some room because I'm going to be saying plus blank in just a minute. And then on the right side of the equal sign, I have my x squared minus 2x. And then here I'm going to write plus blank. Okay, so I take half of the middle coefficient because my leading coefficient is 1. I take half of the middle coefficient, that would be -1, and then square it, I get +1. So I do that to both sides. Coincidentally, we get another -5. And this factors just the way we talked about in the last one. It's a perfect square trinomial. So it factors into the square of a binomial, and you take the square root of the first term, the square root of the third term, and the sine of the middle term. So x minus 1, the quantity squared. All right, I'm going to take the square root of both sides, and I'm going to do a beautiful kind of purpley fuchsia looking color. And write, don't forget plus or minus. You're taking the square root of both sides of a quadratic equation. You cannot forget the plus or minus. Okay, so on this right side, the square and the square root cancel, so I get x minus 1. On this left side, I get plus or minus the square root of 5 and then times I. And so my last step is to get x all alone. So I'm going to add 1, and then I have plus or minus red 5 times I. And those are my two answers, and they are complex conjugates. Okay, all right. I hope that helped, Kenji. All right. Tara, I hope you saw that whole word problem. I did the word problem from the quiz. All right, Kathleen, can I do a problem with complex conjugates? Sure. I'm assuming you want me to do something with complex conjugates, not just solve an equation that has complex conjugates as the solution. All right, so I'll do like number 7 on the quiz, but I'll make something else up. So say they give you, let me write up here, complex conjugates. Sorry, that's messy. All right, let's say they give you -2 plus 6i, and they ask you to write the complex conjugate. Then it would be -2 minus 6i, because you only changed the sign in the middle. So the -2 stayed the same, and then the sign in the middle changes, and then you have your 6i. Okay, so that's just finding the complex conjugate of that. Now if they ask for the product of the two complex conjugates, now you're going to take your -2 plus 6i that they gave you and multiply it by your -2 minus 6i that we just wrote. So if I use the FOIL method to multiply this, my -2 times -2 is +4. My outers are going to give me plus 12i, but my inners are going to give me -12i. So those cancel, and that will always happen when you're multiplying complex conjugates. And then finally, this is my last step, and it is the step that students make the most mistakes on. So I strongly advise you to do this last step in 3 baby steps. Here are the 3 baby steps. So first ask yourself what your sign is going to be. Well, I have a positive times a negative, so isn't that negative? Baby step 2 is ask yourself what is 6 times 6? It's 36. You'd be surprised how many people will put 12 because they're doubling and not multiplying. You are multiplying right now. And then write what you get for your i's. Well, if I take I and multiply by I get I squared. But if we were together, I would say, but what does I squared equal? You better know that I squared equals -1. So doesn't this whole term turn into plus 36? Because my I squared is -1, and -1 times -36 is positive 36. So now I have 4 plus 36, and so my final answer is 40. You will always get a real number when you take the product of a complex number with its complex conjugate. Okay? All right. Kathleen, I hope that was helpful. So Christopher is saying, can I please do something where we name what the answers are going to be like based on the discriminant? Yes, that's a great idea. So let's kind of summarize the chart, shall we? So your discriminant can be one of 4 things. Okay, the positive discriminant can either be a perfect square, I'm going to abbreviate PS, or it won't be a perfect square. Okay, so if you do have a perfect square, I really feel like showing you an example of a solution in the same form as you get when you are using the quadratic formula. Okay, so I'm just making this up. Let's say you had -2 plus or minus the square root of 16. Okay, 16 is my, and then let's say all over 2. 16 is my discriminant, only the 16, so you don't go taking the square root and saying, oh, is the discriminant 4? It is not. The discriminant is 16. That is a positive perfect square. And so if we were to simplify this answer, wouldn't I get rid of my square root and say that instead of that I have 4, and then I'd be able to evaluate what -2 plus or minus 4 all over 2 equals. And I would get 2 real rational roots. Okay, so by showing you the example, I'm hoping that you guys understand that, oh, well, if I have a positive perfect square, the square root would go away because I can take the square root of a positive perfect square. And that means my solutions will be rational, not irrational. And of course, they are real because I didn't have a negative inside my square root. And so there you go. All right, but let's say you had -2 plus or minus the square root of 17 all over 2. 17 is not a perfect square. Okay, so it's positive, but it's not a perfect square. And so we say that we'll have 2 real irrational roots. Because my square root of 17 can't be simplified, that's going to end up being irrational. Okay, a third possibility is that the discriminant is negative, and here's my example. This -2 plus or minus the square root of -4 all over 2. All right, so when you go to simplify the square root of -4, you get 2i. Well, those are, excuse me, complex conjugates. So 2 complex conjugates. Okay, and finally, the last, oops, I usually do that one last. Okay, I forgot 0. So 0 is a fourth one. And so, for example, -2 plus or minus the square root of 0 all over 2. And let me go back and circle in red this discriminant, just the 17, here just the -4, and here just the 0. Okay, so when your discriminant is 0, your square root completely goes away. The square root of 0 is 0. And whether you add or subtract 0 from -2, you only get -2. And then divided by 2, you would get -1 as a double root. Okay, so I usually say, and some of your teachers may say it differently, 1 real rational, and of course it's rational because there is no square root left, 1 real rational double root. Now do not misinterpret that number 1. It doesn't mean, oh, this one all of a sudden only has 1 answer. No, these are all quadratic equations, so of course they have 2 answers. The fact that it's 1 real rational double root, though, tells me that if I had gotten this when I plugged in 0 for my y, then that tells me that I have my vertex at the x-axis, only 1 point on the x-axis, and it's whatever this number ends up being, -1 in this example. So it's a double root, and it means that my vertex lands right on my x-axis. It is the only point on the whole parabola that touches my x-axis. Okay, so we call that 1 real rational double root. Okay, Christopher, I hope that helped. All right, John, do you always take the square root of both sides? Let me go back over one more page, I think. Okay, right here where I have my purple plus or minus sign. Yeah, when I got to that point, I had factored the right side of my equal sign, so I had x minus 1, the quantity squared. Well, I'm trying to get to my x, so I need to get rid of the square. That is why I take the square root. And if I do that to the right side, then I have to do it to the left side. So yes, I'm taking the square root of both sides of a quadratic equation. That's when I want you to say. So don't forget the plus or minus. Okay? And that's how I got my 2 answers. If you don't put that plus or minus, you think your answer is just 1 plus the square root of 5 times I, and it is not. You have 2 answers. Okay. That was John's question. All right, Marin, can you show how to change a y equals blah, blah, blah into vertex form? That's actually the first example that we did. Without doing the whole thing, I'll pick a different equation and do it again. Let's see. You know what? I'm purposely going to pick one that has a leading coefficient. Okay, let me change pages. Whoops, forgot I had gone back. Okay, page 9. Let me make sure. Page 8, it's writing. Page 9. Okay, so I'm picking y equals 2x squared minus 7x. I should probably look at answers and see. I don't have the answer here. B over 2a. Yeah, that's not going to be an integer. Okay, I'm just going to change that to an 8x. And plus 12. I have no idea what this is going to end up being. I'm just making it up. Okay, so if they ask you to change this to vertex form, as I mentioned before when we were doing number 1 from the quiz, actually I didn't do number 1 from the quiz, I did a problem like number 1 from the quiz. All right, so you have to have memorized negative b over 2a. This is by far the easiest way to do this. It's going to be the x coordinate of my vertex, and then we'll figure out the y coordinate by plugging it back into the equation. Okay, so the opposite of b here is 8. 2 times a is 4, and so I get the integer 2. To figure out what my y is, I go back and plug this in. Okay, so 2 squared is 4 times 2 is 8. Then I get minus 16 plus 12. So my 8 minus 16, okay, I end up with 4. There you go. So there's my vertex is 2, 4. Okay, and you have to know your vertex form. Let me write in red. This is vertex form. I'm going to write it out with only variables. Okay, and if you didn't know this from your quiz today, you better figure it out and memorize it. Y minus k equals a, the quantity, x minus h, the quantity squared. Hey, you should make flashcards. That would make it super easy to memorize. By the way, let me write this in red. Look where I have my vertex is 2, 4. That is h, k. And so I'm going to write y minus my 4, because that's my k, equals, and then I'm going to leave that a blank because I want to make a comment about that. My quantity, I'm going to write x minus whatever my h is. Well, it's 2, and then the quantity squared. So the only thing I'm missing from this is my a, and I think some of you don't know how to find it. Well, look at the original equation that they gave us. Let me go back to that pretty purple that they gave us in this equation up here when the equation was in standard form. Isn't my a 2? It's sitting right there. This is y equals ax squared plus bx plus c. And so that's exactly the a in this equation. And so I just put 2 and I'm done. I've written my equation in vertex form. Okay? Okay. We have 15 minutes left. All right, let's see. Joey, when we eyeball another point over the axis of symmetry, do we have to try and label that point? I would say, I mean, if they're integers, let me go back to my graph. I want to point out what I did on my graph, Joey. Okay, right here. See, I did, let me show in red with an arrow. I plotted the point 0, 2, 1, 12, and 2, 10. Okay, I didn't label them on my graph. Well, where the point is, I didn't label, but do you agree? Find the point 1, 10. If you look down at the x-axis, I've labeled my 1, and you look at the y-axis, I've labeled my 10. So even though I didn't literally label the point like this and write 1, 10 right next to that point, on my x and my y-axis, you can tell what my point is, okay? And most of you do not do this 10, 12, 13 that I have up on the y-axis, and you need to, okay? Because then you don't have to label all these points, okay? If you look at the, let's see, how did I get that one? From, oh, they gave me, and I said 110. That's actually not correct. It was 112. That's this one right here. So I was wrong. Okay, that's my 112. Okay, this point down here, that is at a level of 10. That's from my 210. This one right here was 210, and if you look below on the x-axis, you can see the 2 and then the 10. And from that one, I said, if that's 2/3 units to the right of the axis of symmetry, then I tried to go 2/3 units to the left. And that was the point that I did, a point of symmetry. So to answer your question, you don't have to label the individual points. However, I do expect you to label your axes so I can tell where your 1 and 2 and 3 are on your x-axis. And did you go by 1s on the y-axis? Because maybe you'll want to go by 2s depending on what the numbers are. Okay, and that's okay as long as you're consistent. Okay, you'd have to go 2, 4, 6, 8, 10, 12. You can't just skip any. Okay, so just label on your axes, and that's fine. Okay, let's see. That was Joey's question. Okay, Christopher, can you do the problem on the quiz where it says f of x equals some value? Well, number 1 had f of x equals some value. The number 6 had suppose f of x equals this. Yeah, you're going to have to be more specific than that. Well, I guess those are the only 2 that have an f of x. But I think I did a problem just like number 6, and I did number 1 also. So if you have a specific question, you can look in your book and find a question like you're looking for if you'd like, Christopher. Okay, let's go to Maddie's question. Can I please go over complex numbers that are negative? That is interesting. Complex numbers are not real, so that question doesn't really make sense. Okay. You mean a negative exponent. Okay, now I understand, Maddie. I read the next part of your question. All right, so let me get to a blank page. And Savannah's also asking for that. Okay, so why don't we do a few, and we'll have some positive exponents and some negative exponents. Okay, and we'll use your example of 67. Okay, so let's do I to the positive 67th first, and then we'll compare it to I to the negative 67th power. All right, so I to the 67th power. I suppose we should review this too, so I'm going to put it kind of right smack in the middle between our 2 examples. So you need to know the definition of I squared, I cubed, and I to the 4th. So the I definition of I is just the square root of -1. However, I don't want to leave a square root of -1 in an answer, so if I ever do have a negative inside my square root, I would substitute I for it, and that's why I'm circling that in red. Okay, then I'm not going to go over the reasons why. We've already talked about that in class. You need to know that I squared equals -1, I cubed equals -I, and I to the 4th equals +1. And I'm going to go back and circle those right sides all in red because we never want exponents for our i's. Whether they're positive or negative, we never want exponents for I. That one down here is pretty awful. Okay, that's supposed to be my number 1. Okay, so in order to simplify this I to the 64th power, I'm going to use this fourth equation that I to the 4th equals 1 to try to get rid of as many i's as possible. Okay, so I'm going to split this up into I to the something power, we'll talk about that in a second, times I to the something power. So I want to think of the biggest number that's less than or equal to 67 that is a multiple of 4. Okay, if you're not sure, then you start with something that you do know. I think you know that 60 is a multiple of 4. That means I'm going to go up by 4 and say 64 is a multiple of 4. And if I go up one more, I'll be at 68. That's too big. Okay, so I'm going to put 64 right here in this first box. Okay, because 64 is a multiple of 4, I can just cross this out. I can just cross this out and say it equals 1 because that 64 is a multiple of 4. Okay, and so then I need to think about what's my leftover factor. Well, I need to know that when you're multiplying like bases, you keep the same base and you add the exponents. So 64 plus 3 equals 67. So I have 1 times I cubed. So of course that's I cubed, but that's not my final answer because I don't want any exponents for my i's. And so I must know that I cubed equals -I. Okay, so that's my answer. All right, now when I go across the way here to my second example of I to the negative 67, you have to know that that negative exponent means, let me put an arrow right here and try to find my pretty purple. That negative exponent means 1 over dot, dot, dot. All right, so the negative exponent means 1 over, and then what I'm left with is I to the 67th. So this is a whole different situation. Now I have I to the 67th in the denominator. I'm not going to simplify that denominator the same way that I just did this I to the 67th. Rather, I'm going to ask myself, what could I multiply this denominator by, I to the something power, so that I would get a multiple of 4, excuse me, that's greater than or equal to 67. Okay, so the next one, remember we said 64 was a multiple of 4. If I go up to the next one, it's 68. Well, doesn't that mean I need a 1 in this little box so that my, let me write it right here underneath, my I to the 67th times my I to the first, when I add my exponents, I get I to the 68th. Well, that is a multiple of 4. Therefore, I can just cross this out and say that it equals 1, and I just got rid, excuse me, of my i's in the denominator. That's exactly what I was trying to do. You don't want any i's in the denominator. Okay, back to this fraction where I just have a fraction sign, and I wrote I to the first in the denominator. You have to multiply the numerator by the exact same thing so that you're multiplying by 1. I to the first over I to the first is just 1, so I'm not changing the value. So in my numerator, I have 1 times I, and that's just I, and I over 1 is just I. And so that's my final answer. So notice the problems start out looking a little bit similar. I have I to the 67th and I to the negative 67th, but I got 2 completely different answers. Okay, and please don't try to guess what the answer is. It depends what the exponent is. Okay, I will tell you your 4 choices though. They are these red circled numbers. I, -1, -I, +1. Those are the only 4 answers that you can get. Okay, but it's not a guessing game. Okay. All right, Maddie might be typing. We have about 6 minutes left if you guys want anything else done. All right, Maddie's asking to see completing the square. All right, I did do a few problems like that, but let's see. They're going to ask you to solve by completing the square. So let me find an example for you. All right, let's say completing a square. Okay, I want to use a different middle term. Okay, I'm just going to make it up. All right, let's say I have x squared plus 8x minus 11 equals 0. Okay, so I'm going to leave my first term and second term alone. I'm going to bring the constant term over to the other side, so I get 11. Then I'm going to write plus blank, and so I go to my middle term. Because my leading coefficient is 1, I go to the middle term coefficient, take half of it, that's 4, and then add, square it, I mean, and so I get plus 16. And then I have to add the exact same thing right here. Okay, so on this side, right side, I get 27. On the left side, I have a perfect square trinomial. And you guys, you have to be able to factor these. Okay, you should be starting to notice a pattern here that we always get a perfect square trinomial. And so it's going to always factor into the square of a binomial. And here's how you get the binomial. You take the square root of the x squared, that's x. You take the square root of the 16, that's 4. And you take the sign of the middle term. In this case, it's a plus sign. Okay, so then I'm ready to take the square root of both sides. That's called the square root principle. And when we take the square root of both sides of a quadratic, I want you to say to yourself, but don't forget the plus or minus. I really am going to be quite angry at anybody who forgets the plus or minus. We have talked about that over and over and over again. It's a quadratic equation. Of course there are two answers, so you cannot forget that plus or minus. Okay, the square root and the square on the left side cancel, and I get x plus 4. On the right side, I get plus or minus, and then now I'm going to simplify this radical. We haven't done a whole lot of this, but isn't 9 a factor of 27? And it's a perfect square, and then I have a 3. So I get plus or minus 3 times the square root of 3. And then I want x all alone, so I'm going to subtract 4 first, and then say plus or minus 3 rad 3. Okay, now I just made that problem up. So actually it worked out quite nicely. All right, so you had a radical to simplify. Sometimes you'll have a radical with a negative in it. You know what, let me just do an example of, let's say you were at this point where you had x, let's go plus 2 the quantity squared, and then on this side you had plus or, oh no, we haven't done the plus or minus yet. So let's say on this side you have a negative, I'm going to go 50. Okay, you guys have simplified the square root of negative 50 before. Okay, so let's say you're at this point, and so you say, oh, I'm trying to solve for x, so I'm going to take the square root of both sides. But of course, you're going to say to yourself, but don't forget plus or minus, and you're going to put that nice and big and bold right there. You should do it in beautiful colors too. All right, then the square root cancels with the square. I get x plus 2 equals plus or minus, and here's why I wanted to do this example. I'm going to split that square root of negative 50 up into 3 separate square roots. First, I'm going to put 25 in the first one because that's a perfect square. That's a factor of 50. Then I'm going to put 2, the leftover factor, and then I'm going to put negative 1. So don't I get plus or minus 5 times the square root of 2 times I. Do you follow that? Okay, then I want my x all alone. We want to put a first, so that's negative 2 plus or minus 5 rad 2 times I. And that is exactly how I want my students to write the answer because it's a complex conjugate. They are complex conjugates, and I always want complex roots in a plus bi form. Okay, so 2 separate terms with the b in front of the I. Okay, and make sure you write your I neatly enough that it doesn't look like it's partway under your radical. It is not. Okay, Marin, can you find the particular linear equation containing 2 specific points? Okay, so Marin, I'm not sure who your teacher is, but he's referring to a question that was, I believe, R6. And in my class, I omitted that problem because what your book is doing is they're trying to make you kind of see that, hey, sometimes you have a quadratic equation, but other times you might have a linear equation. And that's all good and fine. However, we are testing you guys on quadratic equations, okay? So you're not going to have a linear equation on the test. So there, Marin, I just told you it's not on the test, so let's not worry about it, okay? Now you should be able to write an equation with 2 points and a line, but you know what? That was our chapter 3 test. You should go back and review that if you don't know how to do that. Okay, it is 8:30. We're going to take a break, and I will see my students tomorrow. The rest of you, good luck with your tests and study hard. All right, see you tomorrow. Hope that was helpful. Bye-bye.